Hey guys, welcome to Algebra 1. I'm Ms. Flowers and I work for Math Nation. During this time together, we will cover Mississippi Algebra 1 Standard A-REI.12 by graphing a system of inequalities written from a real-world situation using the Desmos calculator and exploring the shaded region. We will also discuss CED.3 by interpreting whether solutions are reasonable or not reasonable in the context of the problem. You can join me today by gathering a few things that you could need. It would be paper, pencil, colored pencil, and a device that you could use Desmos on. Now you can download Desmos on iPad, iPhone, Android devices, and you can also use it on the web. You can also find Desmos in the Algebra 1 section of Math Nation. So let's get started. We need to pull up your previous memory of inequalities. So I have a warm-up problem. 2x minus y plus 6 is greater than 0. Now remember, an inequality means that you will not have just one solution, but you will have a set of solutions. So we're going to set this to standard form because the word problem we'll be using in a few moments will all be set to standard form. So we need to remind ourselves, what does standard form look like? Well, we need to make sure that our variables are on one side and our constant is on the other. So what do we have here that we need to move to the other side? The 6, correct. So with this 6, we need to make sure that we move it over to the right side. Well, in previous lessons, we have learned that to move things across an equal sign or an inequality sign, you have to do the inverse or the opposite. So what is the inverse of plus 6? If you said minus 6, that is correct. If you said negative 6, that is also correct. Remember, the minus and the negative are the same thing. So we're going to subtract 6. 6 minus 6 gives you 0, or they do cancel out. Now also remember that when you have an inequality or an equation, it is like a balance. So when you have the balance, that balance has to stay equal. If you take too many things away from one side, the other side could get heavy. So you have to remember to take away from both sides. So since I did it to the left side, I'm going to also subtract 6 from the right side. So 0 minus 6, negative 6. So we're going to bring down the 2x and the minus y because we have not used those, and our inequality symbol. So we have 2x minus y is greater than negative 6. So let's go to Desmos, and we're going to look at how does Desmos show us the shaded region. So I'm going to type in the inequality that we have, and I'm going to use the keyboard on Desmos so that you can see the keystrokes that I'm using to type it in. So I have 2x minus y is greater than negative 6. So as you can see, it graphed it for me, and I do have a boundary line. Remember, this boundary line is a dotted line, and that tells us that everything on the boundary line is not included in our solution. And you can also see that everything in the shaded region, which is below the boundary line, will be included in our solution, and everything above the boundary line will not be included. So now let's go to our word problem that we are going to look at and see if we can find a system of solution so that we can solve this real-world situation. First thing, let's read the problem. You have 2 part-time jobs that pay $11 an hour for mowing lawns and $8 an hour for washing cars. You want to make at least $150 a week, but work less than 20 hours per week. How many hours should you work at each job? Write a system of inequalities to represent this situation. So let's look. Where was the question for this problem? Well, the only question that I see is how many hours should you work at each job? So what question are we answering? You're right. We're looking for the hours. We're looking for the hours for each job. Let's go back up into the beginning of the problem, and we're going to start looking for the information that is given to us. So at the beginning it says you have 2 part-time jobs. So I'm going to underline the 2 because it tells me I have 2 separate jobs. So I'm going to be looking for 2 different sets of information. So the first one, $11 an hour for mowing lawns. So I have $11 an hour for mowing lawns. So the next one that it gives us, $8 an hour for washing cars. $8 an hour for washing cars. So we do see that it gives us 2 separate sets of information for the 2 equations or the system of inequalities we will be writing. So now let's go to the next sentence because we need to look and see if it gives us a total. You want to make at least $150 a week but work less than 20 hours per week. So let's look at why is this going to be an inequality instead of an equation? Well, I have a keyword right here that will tell me. You want to make at least $150. So let's take a guess and think, what could we buy for that $150? Oh, what if there's a pair of tennis shoes that you would like to buy? That's $150. Now you will need at least $150. Could you use less? Well, if I only had $100, would I have enough for the tennis shoes? That's right. No, I wouldn't. So at least $150 would mean that I need the $150. Could I have more? Well, if I had $160, would I have enough for the tennis shoes? You're right, I would. So at least means I'm going to need that amount, but I can also have more. So let's take this money and we're going to use that at the end of our inequality and start building our equation. So I have my money. $150. Now we need to look at least. At least, does that mean it's going to be greater than $150 or less than $150? Well, we talked about the tennis shoes, and that would mean that it is greater than $150. But it could also equal the $150 because we needed the $150 for the tennis shoes. So now let's look at the second total it gives us. The second total is, I want to work less than 20 hours per week. So if you're studying for semester test, but you still have a job, you know that you're going to have to make time for studying as well as that job. So you set a time in your head that you go, I know that I cannot work more than 20 hours a week to have time for studying. So we know this is one of our totals. Now, am I going to have a greater than sign or a less than sign? Am I going to work more than 20 hours or less than 20 hours? I heard you. You said less than. Good job. So less than 20 hours. And I don't believe, let's look back up in our problem. Less than 20 hours does not mean that 20 would be included. It would mean less than. So that is our correct sign. Now we have to decide what is going to go on the other side of our inequalities that are going to add up to give us that. So let's go back up into our equation and we're going to look for things. Now remember, the $150 is money. So we need to find money that's going to add up to money. Well, because money has to add up to money, right? So will hours add up to... Did you say oranges? Oh, you're so silly. Hours are going to add up to hours. So we're going to look for money that adds to money and hours that add to hours. So let's find our money. I see $11 and I see $8. So I'm going to circle those. $11 and $8. I have 11 and I have an 8. Something seems funny about that because 11 plus 8 is not going to give you 150. There's something we're missing in that problem we need to go back and find. So we have $11 an hour or per hour for mowing lawns. Do we know how many hours? Ooh, I heard somebody say it. That was our question. We were looking for how many hours. That is our unknown. So we need to go back and name these so that we can use them in our inequality even if we do not know them. So what have we learned before that we have named unknowns with? If you said variables, you are correct. So we can use any variable, but how about for this one we just go ahead and use X and Y. So I'm going to name mowing lawns X, and I'm going to name washing cars Y. Those are our two unknowns. So now I'm going to put mowing lawns with the 11, and I'm going to put washing cars with the 8. Now am I going to add them together to get my 150 or am I going to subtract? Excellent. I'm going to add them. So now I have my money inequality. Now I need to look for my hours inequality. Remember, I'm only going to add hours to get hours. I'm not going to add money to get money. So we do not need the 11 and the 8 in this second inequality. So what two things do we have that show hours for washing cars and mowing lawns? Good job. The variables, we just named those. So we need to add those variables together. So we're going to add X and Y together. So the number of hours mowing lawns plus the number of hours washing cars should be less than 20 hours because we're trying to find time to study. And again, to review, $11 per hour mowing lawns plus $8 per hour washing cars, we want it to be greater than or equal to $150 so we can buy those tennis shoes that we want. So now what we're going to do is we need to see this model. We need to look to see what this will look like. So let's look at it on Desmos. I have it already graphed. So we have the 11x plus 8y is greater than equal to 50. And we have the x plus y, which is less than 20. So as you can see, we have two different shaded regions. The red shaded region is our money. And our money, we did want it to grow. So you can see it is continuing to go up on the graph. The orange section is your hours that you are working, and we wanted it to stay below 20 hours. So you can see that it is below your boundary lines. But what we are trying to accomplish is the two jobs that we have, how many hours can we work at both jobs and still make that amount of money? So let's test a few things on our graph. Our x-axis is the mowing lawns, and the y-axis is our washing cars. So let's look. Can we mow 18 lawns and wash 5 cars? Well, we could, and that would give us the more than $150 we want, because that would be right here, but that is outside of our orange. And what was our orange? Our orange was the amount of hours that we worked. So we wanted to make sure we stay within the 20 hours. So let's test another one. Can we mow 5 lawns and wash 5 cars? Well, that does keep us below the 20 hours, but it does not give us the more than or at least $150 that we would want for that week. So reading the graph shows that all of our solutions would need to be within this double shaded region. So that's why we look at the model to see where would the different hours for the 2 different jobs fall. So let's do a maze that we could actually use this, and we're going to look at the different ways, or kind of pull together the things that we have already done today. So here is the problem that I did. This is the real world situation. And now we're going to eliminate with what we have. So this is just like looking at the map test or something that you would see, and you would have choices like A, B, C, and D. So let's use elimination and see if we can find the correct equation. Okay, so I'm going to look at the 20 hours first. We have less than 20 hours, greater than 20 hours, less than 20 hours, and greater than 20 hours. So the 20 hours was the total amount of hours that we wanted to work. Was it less than 20 hours, or was it greater than 20 hours? You're right, it was less than 20 hours. So both of these with the greater than 20 hours can be eliminated. Now let's look at the money. The money, we have greater than equal to $150 and less than $150. Which did we want? That's right, you remembered those tennis shoes. The tennis shoes that we wanted cost $150, and you needed at least the $150, not less. So you were able to eliminate the 3 choices just by looking at the totals. Now we have graphs to look at. So let's decide how to eliminate the graphs. In this top graph, I see orange and red that are both shaded below the boundary lines. Well, remember that we wanted our money to grow, and the money was the red. So in this model, the money would be decreasing and the hours would be decreasing. Did we want the money to decrease? No, we didn't. So we eliminated this graph to be the model for this problem. Let's look at this one. We have 2 boundary lines, and both boundary lines look like they are growing. So the hours would be increasing and the money would be increasing. Did we want the hours to increase? No, we wanted the hours to decrease. So we can eliminate this one. So if you look, this is the same graph that we had when we were looking at it on Desmos. So we have the hours in the orange where the hours were shaded in the decrease. We have the money where the money was increasing, but we also have this shaded area right here that we can look and see how many hours we could work mowing lawns and washing cars. So now we have 2 different choices. So let's look and see which one would be a reasonable choice and which one would be a not reasonable choice in the context of the problem. So we have 14 hours mowing lawns and 2 hours washing cars. So to do this, we're going to place it on the graph and find and see if it is in the double shaded region. So I have 10, 11, 12, 13, 14 lawns, and 1, 2 cars. So my point for that one would be here. Is that a reasonable solution for this problem? Good job! It is not a reasonable solution for this problem because we needed to stay below the 20 hours and be above the $150. But this is above the 20 hours, so this would be too many hours and we wouldn't have time to study. So that eliminates this one. Now remember, we can't just take that particular answer and go, oh, that's it. We have to double check and make sure we did not make a mistake. So let's look at 11 hours mowing lawns and 2 hours washing cars. So we have 10, 11 hours mowing lawns and 1, 2 hours washing cars. So this point would be here. Is that a reasonable solution for this real-world situation? If you said yes, you are correct. It does fall within the double shaded region, so you know that it is going to be above. You will earn more than the $150 you wanted for the week, but you are also working less than the 20 hours per week you wanted to work, so that you would be able to study. Very good job. Wow, you have all done so great today. I'm so proud that you had stayed with me and helped me through systems of inequalities. We wrote the system of inequality from a real-world situation. We graphed it on Desmos, and we looked at test prep and eliminated by looking at the model of the graph. You should be proud of yourself too. This activity is available in the teacher area of Algebra 1 on Math Nation. So proud of you today. Thank you for joining me. See you next time.